In the spring of 2023, a group of researchers, including a team from Baylor University, sat down with years of gravity data collected by NASA's GRAIL mission and turned their attention to the moon's far side. What they saw on their screens shouldn't have been there. Nearly 200 miles beneath the floor of the largest, oldest impact scar in the entire solar system sat a mass of unidentified material, so dense that it was visibly warping the moon's gravitational field. The team rechecked their calculations, then checked again. The instruments weren't malfunctioning. The anomaly was real, and it was massive, roughly 218 million cubic kilometers of extra density packed into one region, translating to an added mass in the quintillions of kilograms. To make that number tangible, if you spread that hidden material evenly across the floor of the basin above it, it would form a layer more than half a mile thick. No one predicted this. No one had planned for it. It had simply been sitting in the data, a structure larger than almost anything ever detected inside a rocky world in our solar system, undisturbed for nearly 4 billion years, until someone finally noticed. This isn't a story about an odd rocket. It's a story about how one of the most familiar sights in our sky, the same gray disk humans have stared up at since before written language, watched by every civilization that ever looked skyward, turned out to be concealing something that reshapes our understanding of how planets like ours actually form. And by the end, you'll see exactly why this finding didn't just sit quietly in an academic journal. It's now one of the reasons NASA has redrawn where astronauts will land what they'll search for, and what might be waiting for them when humans return to the lunar surface for the first time in more than 50 years. For most of the 20th century, the moon was treated as settled science. Between 1969 and 1972, 12 astronauts walked its surface across 6 Apollo landings, gathered rock samples, planted flags, and came home. Then for more than 50 years, no human ventured past low Earth orbit. Again, robotic missions kept working quietly in the background. Orbiters mapped the surface in ever finer detail, but the age of boots on lunar soil simply ended. In the popular imagination, the moon became a closed case gray, dead cratered, fully understood the way an overfamiliar photograph feels understood. What most people outside the scientific community missed is that the closer researchers looked with modern instruments, the less settled the picture actually became. New radar sweeps, gravity readings, and spectrometer data kept surfacing details that didn't match the simple story most of us carried around. It was against that backdrop that NASA formally committed to Artemis, named for Apollos, twin sister in Greek mythology. A program built not to repeat the past, but to go somewhere. Apollo never attempted the lunar South Pole. The South Pole looks nothing like the flat, sunlit equatorial plains Apollo astronauts walked. Because of the tilt of the moon's axis, some deep polar craters never receive a single ray of direct sunlight, not for a day, not for a year, but potentially for billions of consecutive years. Scientists call these permanently shadowed regions, and inside them, temperatures drop low enough to trap substances that would evaporate almost instantly anywhere else on the surface. In 2009, NASA intentionally crashed a spent rocket stage, the L-Cross mission, into one of these shadowed craters and studied the resulting debris cloud for chemical signatures. It confirmed something scientists had long suspected but never proven: water ice sitting at the bottom of that crater undisturbed for an almost unimaginable stretch of lunar history. That discovery alone would have justified decades of follow-up work. It turned out to be just the first chapter. In the years since India's Chandrayaan missions found water molecules distributed more widely across the lunar surface than expected, not just trapped in shadowed craters, but chemically bound into the regolith, the loose blanket of dust and broken rock covering the moon. In August 2023, Chandrayaan-3 went a step further, becoming the first spacecraft ever to achieve a soft landing near the lunar South Pole, succeeding just days after a Russian lander attempting the same feat had crashed. That achievement highlighted both how difficult the region is to reach and how much international interest had already gathered around it, well before any astronaut was scheduled to go anywhere near it. NASA's Lunar Reconnaissance Orbiter, circling the moon continuously since 2009, used radar and neutron spectrometers to map where ice deposits were concentrated, gradually turning the South Pole in scientists' minds from a barren wasteland into something closer to a frozen reservoir. Harsh, shadowed, and resource-rich, this is exactly the terrain Artemis was built to explore. Not Apollos, safe sunlit plains, but ground where a lasting human foothold might actually be sustainable. And where something far stranger than ice had been waiting all along. Artemis launched on November 16, 2022. An uncrewed test flight meant to prove that the new Orion spacecraft and Space Launch System rocket could safely carry astronauts to the moon and home again. It worked. Orion traveled farther from Earth than any human-rated spacecraft before it looped around the moon's far side and splashed down safely in the Pacific. 25 days later, an unambiguous success. While public attention stayed on the rocket and capsule, a quieter story was unfolding inside decades of archived orbital data, one that had nothing to do with engines or heat shields and everything to do with what lay buried beneath the lunar crust. That story broke in 2023 when the Baylor team published findings based on gravity measurements. The twin GRAIL spacecraft had collected back in 2011-2012, flying in tightly synchronized formation and tracking tiny variations in the moon's gravitational pull with unprecedented sensitivity for an entire planetary body. Gravity isn't uniform across a planet or moon denser material, tugs slightly harder on a passing spacecraft. Less dense material tugs slightly less. Measure those differences precisely enough, and you can effectively X-ray what's underground without drilling a single hole. When researchers aimed that gravitational X-ray at the floor of the South Pole-Aitken Basin, one of the oldest, largest impact craters in the solar system, roughly 1,300 miles across, they found the anomaly that opened this story, a body of unusually dense material sitting about 160 miles below the surface with an estimated mass in the quintillions of kilograms. The leading theory is almost as extraordinary as the find itself. This could be the surviving metallic core of the asteroid or planetary fragment that slammed into the moon and carved out the South Pole-Aitken Basin more than 4 billion years ago during the chaotic early days of the solar system. If that holds up buried beneath the moon's oldest and largest scar, may be the metallic heart of the very object that made that scar a fragment of another world entombed inside our own for over 4 billion years. This isn't an unusual mineral deposit. It may be the last physical remnant of a body that no longer exists anywhere else in the solar system. Evidence of a collision that predates Earth's continents, predates anything resembling life. It's sat undetected through every era of human observation, naked eye astronomy telescopes, even the Apollo landings themselves invisible until instruments sensitive enough to map its gravitational signature finally passed overhead. There's another mystery that predates both of these findings. Lunar swirls. Scattered mostly across the moon's near side are pale looping patterns that look almost painted onto the ground, some stretching for dozens of miles in shapes that follow no obvious geological logic. The most famous Reiner Gamma has puzzled scientists for decades. Researchers eventually found that these swirls line up almost exactly with small localized patches of magnetic field on the surface, patches that are strange in their own right since the moon, unlike Earth, doesn't currently generate a global magnetic field. Somehow, in isolated pockets, magnetism persists, deflecting the steady stream of charged solar particles that would otherwise gradually darken the surface, leaving the pale swirls behind where that deflection happens. Nobody has proven where these localized fields come from. Some suspect a link to buried metallic deposits possibly related to the same kind of ancient impact material behind the South Pole-Aitken Basin. Anomaly, others think the swirls might be leftovers from a global magnetic field the moon once generated on its own before its core cooled and that field shut off permanently. Either way, the underlying point is the same. There's far more buried unexplained structure inside the moon than the simple geologically dead picture most people still hold on to. Getting to these discoveries in person hasn't been simple. In 2024, NASA disappointed much of the lunar science community by canceling Viper, the volatiles investigating polar exploration rover, a mobile robot built specifically to drive into the permanently shadowed craters near the South Pole and sample the ice deposits found over the previous decade. 10 days later, on April 10, 2026, the crew splashed down safely in the Pacific, off the California coast, having completed a full lunar flyby and proven that Orion and the Space Launch System could keep a human crew alive on the full round trip. It was by any measure a triumph, clearing the single biggest hurdle standing between Artemis and an actual crewed landing, but the story took another turn almost immediately. Rather than moving straight from Artemis II to a lunar landing, NASA added another mission to the program's architecture, a crewed flight in Earth orbit specifically designed to test rendezvous and docking between the Orion spacecraft and the commercial lunar landers, being built by SpaceX and Blue Origin, a critical rehearsal before anyone attempts to actually set a human-rated lander down near the South Pole. In June 2026, NASA named the crew for that mission and for the crewed landing that follows it. Commander Randy Bresnik, a former Marine fighter pilot, Top Gun graduate and veteran of the Space Shuttle and International Space Station, will lead the flight, joined by pilot Luca Parmitano of the European Space Agency, and mission specialists Andre Douglas and Frank Rubio. NASA has confirmed that this crew, or the landing mission that follows, will include the first woman and the first person of color to walk on the lunar surface. The actual crewed landing is now targeted for 2028, pushed back from earlier plans mainly because SpaceX's Starship human landing system still needs to demonstrate orbital refueling, and complete an uncrewed lunar landing test before anyone risks a crewed descent to that harsh, shadowed polar terrain. It would be easy to read that delay as bad news, and on pure schedule terms, it is a setback. But look at what it actually reflects. NASA declining to rush a landing near the most scientifically significant, most treacherous terrain on the entire moon ground, sitting directly above a buried mass anomaly. Nobody fully understands, laced with lava tubes and permanently shadowed craters that may not have seen sunlight in billions of years. Every extra test, every Earth orbit rehearsal, every uncrewed landing demonstration is being built to make sure that when humans finally do set foot near the South Pole, they're ready for terrain, unlike anything Apollo astronauts ever faced, and close enough to some of the biggest open questions in planetary science to actually start answering them. Consider everything now sitting within reach of that eventual landing site, a mass of unexplained density, quite possibly the metallic remnant of an ancient cosmic collision buried nearly 200 miles beneath the oldest, largest impact basin in the solar system. A lava tube, potentially stable enough to shelter future explorers hidden just beneath a pit that sat in plain sight the whole time. Apollo astronauts explored nearby decades ago, patches of localized magnetism carving pale, swirling patterns into the ground, hinting at buried structure nobody has fully explained. And ice deposits capable of sustaining a long-term human presence locked inside craters that may not have seen direct sunlight in billions of years, waiting in total darkness for the first human hand or the first rover capable of finally reaching them. None of this was visible to the naked eye. None of it was detectable from Earth with any telescope built before the space age. It took gravity, satellites flying in careful formation, radar systems bouncing signals off the ceilings of buried caverns and magnetic sensors, sensitive enough to detect the faintest trace of a field that by conventional expectation shouldn't exist on a supposedly dead world. Every one of these discoveries came from instruments built by people patient and curious enough to keep looking closer at something the rest of the world had already written off as fully explored. There's a real chance that when astronauts finally stand at the lunar South Pole, walking across ground shaped by an impact more than 4 billion years old, looking down into craters that have never seen sunlight, they'll be standing directly above evidence that helps answer one of the oldest open questions in planetary science: how worlds like our moon, and by extension worlds like Earth, actually came to be built in the first place. The buried material may hold direct physical evidence of the violent process of planetary formation itself, the collisions and mergers that assembled rocky worlds from the debris left over after the sun's birth. Understanding what that mass really is, the metallic core of an ancient impactor or something else entirely, could reshape how scientists think about how often and how violently young planets like Earth once collided with the debris still swirling around them in those first chaotic hundreds of millions of years. There's also an international angle easy to miss from a distance. Artemis isn't a NASA-only project. Under the Artemis Accords, dozens of countries have signed on to a shared framework for exploring the moon, and multiple space agencies are now flying their own orbiters, landers, and instruments toward the same South Pole region NASA is targeting. That means the emerging picture of what lies beneath the lunar surface is being built not by one nation working alone, but by a genuinely global effort. Each mission adding another layer of gravity data, another radar sweep, another magnetic reading to the same unfolding puzzle. Japan, the European Space Agency, and a growing list of private companies working under NASA's commercial lunar payload contracts have all sent or are preparing to send their own instruments toward the same general region. Each one, another set of eyes, examining the same buried mystery from a slightly different angle. In a strange way, the moon has become one of the few places in the solar system where the search for answers is accelerating simply because more of humanity is looking at once, comparing notes and building on each other's work in something close to real time. The moon orbits roughly 20,390 miles from Earth, close enough to dominate our night sky for the entire span of human civilization, far enough to stay permanently out of reach until 1969. We named it, tracked its phases, built calendars and religions around it, mapped its surface by eye for centuries, and eventually walked across a small fraction of it. And after all that, after 50 years of assuming the story was finished, it turns out we'd barely scratched its surface in the most literal sense. There's a hidden world beneath the visible one, a dense buried mass, an ancient impact, remnant stable underground caverns, and pockets of magnetism. Nobody can fully explain all sitting quietly beneath the ground. The next generation of astronauts is preparing to walk on. The central question remains genuinely open, and nobody has answered it. Yet what exactly is buried beneath the South Pole-Aitken Basin, and what will it ultimately tell us once human explorers and their instruments are finally standing close enough to find out? The mission is already in motion. The crew has already been named. The landing sites are already being narrowed down with this hidden structure in mind. And sometime in the coming years, for the first time since the last Apollo mission left the surface, in December 1972, human footprints will once again mark the lunar dust, this time within reach of a discovery that has been waiting patiently in the dark for over 4 billion years for someone to finally come looking. Whatever those astronauts ultimately find down there, one thing is already certain. The moon stopped being a solved problem the moment we finally learned how to look beneath it, and it will likely keep surprising us for as long as we keep digging.